This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The central idea is simple. A freestanding deck does not get to borrow structural help from the house. It has to carry its gravity loads into the ground, and it has to resist horizontal movement as its own structure. That distinction is easy to blur because a freestanding deck may sit very close to a building. The distance is not the heart of the definition. The structural relationship is. If the deck is not relying on a ledger connection to the building, the posts, beams, footings, anchors, and bracing have to form a complete system. I want you to remember one sentence through the whole lesson. Freestanding means it borrows nothing. That sentence keeps the foundation decision, the beam connection, and the bracing requirement tied together. Start with the load path. Decking delivers load to the joists. The joists deliver load to the beams. The beams deliver load to the posts. The posts deliver load to the footings, and the footings deliver load into suitable soil. That is the vertical path. The deck also needs a horizontal path. Wind, seismic movement, and people moving across the deck can create racking forces. An attached deck may transfer part of that resistance into the building through its approved connection. A freestanding deck cannot depend on that. It must be positively anchored or designed to be entirely self-supporting, with bracing that controls lateral movement. This is where field supervision matters. A frame can look strong while every member is still square and newly installed. The real question is what prevents the post from leaning and the frame from racking after the deck is loaded. If that answer is only the stiffness of the nails or the weight of the decking, the lateral system has not been clearly resolved. I also want to separate one common confusion. The ledger-specific tension connection used on an attached deck is not a substitute for the internal bracing required by a freestanding deck. The exact bracing arrangement must come from the prescriptive provisions, approved plans, or an engineered design. The supervisor should not invent a brace pattern because it looks reasonable. Now take that self-supporting idea down into the soil. Exterior load-bearing footings generally have to be placed not less than 12 inches below the undisturbed ground surface. The important words are undisturbed ground. A footing is not made compliant by placing a shallow pad on loose fill and measuring from the top of that fill. The footing width, thickness, reinforcing, and total design still depend on the applicable prescriptive rules, loads, soil conditions, approved plans, and any required engineering. The 12-inch depth is a minimum depth rule from the source material. It is not permission to improvise the rest of the foundation. There is a narrow exception that is worth memorizing because all of its conditions have to be true at the same time. Subgrade footings are not required when the deck is entirely freestanding. The deck area is no more than 200 square feet, and the walking surface is less than 20 inches above grade, at any point measured within 36 inches horizontally from the edge. When all three conditions are met, the joists may bear on precast concrete pier blocks set at grade. I put the three conditions into one checklist because the mistake is usually not forgetting the whole exception. The mistake is remembering only one part of it. A contractor sees a low deck and thinks pier blocks are automatically allowed. Height alone is not enough. The deck also has to be freestanding and within the area limit. Imagine a contractor building a hypothetical platform that is 12 feet by 15 feet. The area is 180 square feet. The walking surface is 18 inches above the surrounding grade, and the structure is completely freestanding. Based on the source material, that platform satisfies the three stated conditions for the pier-block exception. Now change only one fact. Suppose the same platform is attached to the house with a ledger. The exception no longer fits because the structure is not freestanding. Or suppose the platform remains freestanding, but grows beyond 200 square feet. Again, the exception no longer fits. This is a good example of a code exception acting like a 3-key lock. Every key has to turn. For inspection readiness, verify the classification and dimensions before the crew starts setting blocks or digging holes. A wrong foundation assumption is expensive to discover after the framing is standing. At the top of the footing, the post base has two separate jobs. It has to restrain the post against lateral displacement, and it has to manage the relationship between wood and moisture. A deck post bearing on a concrete footing must be laterally restrained. The source material allows that restraint through a manufactured connector, or through a minimum 12-inch embedment in the surrounding soil or concrete. Those are not casual substitutions. The selected detail still has to match the approved design and the conditions of the project. For a post supported above concrete, the wood column must project at least 1 inch above the concrete surface. Where the clearance is measured above exposed earth, the minimum is 6 inches. Those numbers are easy to mix up, so I connect them to the surface below the wood. Concrete gets 1 inch, exposed earth gets 6 inches. This reference chart separates the post clearances from two nearby decay protection rules. Wood joists in crawl spaces or unexcavated foundation areas must be naturally durable or treated when they are closer than 18 inches to exposed ground. Wood girders in those areas must be naturally durable or treated when they are closer than 12 inches to exposed ground. The post number, the joist number, and the girder number solve different conditions. I would not combine them into one vague rule about keeping wood off the dirt. For exam preparation and field inspection, the member and the supporting surface matter. The moisture principle is useful here. End grain behaves less like a sealed block and more like a bundle of tiny straws. When the bottom of a post sits against damp concrete, moisture can move into the wood. A raised metal base interrupts that direct moisture path. The practical effect is reduced wetting at the most vulnerable end of the post. Pressure treatment does not turn a poor detail into a good detail. The clearance and support requirements still have to be followed. During a framing inspection, I would look for the correct connector, the required standoff, proper fasteners for that connector, and a clear load path into the footing. The next critical handoff is where the beam meets its support. Beam ends need at least 1 1/2 inches of bearing on wood or metal, and at least 3 inches of bearing on concrete or masonry. The bearing has to extend across the width required by the detail. It is not enough for the beam to touch a corner of the support. A built-up beam creates another inspection point. Every ply has to receive full bearing at the post. An outside ply cannot hang beside the post and rely only on face nails into the supported ply. The vertical load from that outside ply still needs a direct path into the support. The chart puts the bearing numbers beside the connection rules. When a deck beam connects to a supporting wood post, the source material requires a manufactured connector. Toe nailing is prohibited for transferring the structural load. The simplest way to understand that rule is to separate support from attachment. Direct bearing gives the load a downward path through the post. The connector keeps the members properly engaged and resists displacement according to its design. Angled nails driven through the side are not an acceptable substitute for that required connection. Imagine a hypothetical 3-ply beam landing on a post that supports only 2 plies. The third ply is face nailed to the others, but has no support directly below it. The frame may look complete from one side, yet the outside ply does not have the required bearing. The correction is not to add a few more nails. The support or engineered connection has to provide full bearing for every ply. This is also why connector installation cannot be reduced to the phrase metal is metal. A connector has a specific configuration, fastener schedule, and load function. The field decision should follow the approved plans, the connector listing and instructions, and the applicable code path. Return to the freestanding distinction. Once the posts and beams carry vertical load, the deck still has to resist racking. A tall rectangle made from posts and beams can deform sideways unless a lateral system stabilizes it. Diagonal bracing or knee bracing is commonly used in prescriptive freestanding deck construction, but the exact arrangement cannot be guessed from appearance. Brace size, location, angle, fastening, deck height, and tributary loads can change the design. The correct field approach is to follow the prescriptive detail that actually applies, or follow the approved engineered detail. A useful supervision question is this: if the house disappeared, what keeps the deck stable? I answer that question by tracing the braces, anchors, posts, and footings. If the answer depends on a connection that does not exist, or on a decorative skirt that is not a structural bracing system, the deck is not demonstrating independent stability. This is a connected load path problem. Vertical loads move down. Lateral loads need a path into the bracing, through the posts and anchors, and into the foundation and soil. The same deck can have excellent beam bearing and still be deficient in lateral resistance. One correct connection does not repair a missing system. For inspection sequencing, the bracing and connectors should remain visible until the required inspection is complete. Concealing the critical hardware or covering access before approval can create avoidable rework even when the underlying detail was intended to be correct. Deck framing also creates an elevated work safety issue. Effective July 1st, 2025. The California Occupational Fall Protection Trigger for covered residential wood framing activities is 6 feet. The rule applies to employees walking or working on surfaces such as top plates, joists, rafters, trusses, or beams when they are exposed to a fall of 6 feet or more. Conventional protection includes guardrails, safety nets, or personal fall arrest systems. I put the current trigger and permitted methods into a short reference table, because the outdated number is a real source of confusion. The former 15-foot threshold should not be carried into current planning for the covered work. A site-specific fall protection plan is not the first choice simply because harnesses are inconvenient. According to the source material, the employer may use that kind of plan only after demonstrating that conventional methods are infeasible or would create a greater hazard. Consider a hypothetical crew setting beams on posts 9 feet above the lower level. The supervisor should not treat the work as exempt merely because it is below 15 feet. The current 6-foot trigger has already been reached. Before the employees move on to the exposed framing, the contractor needs a compliant method in place. I would coordinate that protection before the lift or framing sequence begins. Waiting until a worker is already standing on the beam turns a planning duty into an emergency correction. Here is the field supervision sequence I want you to carry away. First, classify the deck correctly. Decide whether it is genuinely freestanding or structurally attached. Then verify that the foundation follows an applicable prescriptive design or an approved engineered design. Next, confirm whether the narrow pier-block exception applies. All 3 conditions have to be satisfied. If it does not apply, verify that the footings reach the required bearing condition and minimum depth in undisturbed ground. At each post, check lateral restraint and decay clearance. At each beam, check the required bearing length, the manufactured connection, and full support under every ply. Then trace the lateral system. The deck has to brace itself without relying on the nearby building. Finally, coordinate fall protection before employees enter the exposed framing area. The current trigger is 6 feet for the covered residential wood framing work, and an alternative plan requires a documented basis rather than convenience. The memory connection is short. Freestanding means it borrows nothing. It does not borrow a foundation assumption, it does not borrow beam support from a few angled nails, and it does not borrow lateral resistance from a house it is not structurally connected to. I made an audio practice quiz specifically for the material in this episode. It is audio-based, so the questions are read aloud and you answer by tapping. I designed it for people studying while driving, working, or moving through a busy day. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the footing exception, post clearances, beam bearing, bracing, or fall protection. I read those questions because they show me where a rule still feels unclear. Subscribe so you can stay on track through every episode until you get your license. I know this process takes discipline, and I want to keep helping you turn scattered code numbers into field decisions you can actually remember.